span AB. Now the support B has settled by an amount del, which is also subjected to some applied load. Okay. Now it will develop an additional moment due to settlement of support. From the basic mechanics of solids, might have studied about this moment due to settlement of supports. The moment is 6EI del by L squared and the reaction is 12EI del by L cube. Now in this slope deflection equation, you have to add the moment due to settlement of support. So in this case, the right support settles, which induces an anticlockwise moment at both ends. So which is negative. So whenever the right support settles, it induces anticlockwise moment. Sometimes left support also may settle. In that case, the moment induced is positive, clockwise direction. Now the slope deflection equation becomes final end moment MAB, which is equal to MFAB plus M dash AB. That is due to applied load, then MS, that is the moment due to settlement of support. Similarly, at the other end also we have to add the moment due to settlement of support. By adding the moment due to settlement of support is 6EI del by L squared. If you take now already we have in slope deflection equation outside the parenthesis, that is 2EI by L. So if you take 2EI by L from 6EI del by L squared, you will get finally 3 del by L. So you have to add this coefficient in the slope deflection equation. Now this is the complete slope deflection equation incorporating the slope as well as the displacement. Now we will see the steps involved in the slope deflection method. The first step is you have to list down all the unknown rotations as well as the displacement, that is the settlement or sway for the structure given. So there will be unknown rotation at the joints which have freedom for rotation, like an intermediate joint, simple support. So accordingly there will not be any rotation at the fixed end. So next step is find the fixed end moment for each span due to applied load. That is, we are restraining the support from the rotation. And I will later slides I will give you the list of different structures with the different loads and their fixed end moment. Next you have to form the slope deflection equation. So each span will have two equations corresponding to their ends. Suppose in this case if you take AB, you will have two slope deflection equation, MAB and MBA. Next you have to form the equations of equilibrium. So you have to define equations of equilibrium at a joint. For example, if you take joint B in any intermediate span, the moment MBA and the moment MBC, that is the previous span moment and the next span moment, summation is equal to 0 if there is no applied moment. If there is applied moment, then instead of 0 you have to substitute the applied moment. Next you have to find out the unknown rotations. If there is sway, that also become an additional unknown, that also you have to find out. Next to substitute the value for these unknown rotations in the slope deflection equation. Then you will find the end moments. And finally you have to draw the CFOs and bending moment diagrams. So here the list of fixed moment for different loading conditions I have given. The first case is a fixed beam subjected to a concentrated load at midspan. The end moments are PL by 8 at A, which is anti-clockwise, and PL by 8 at support B, which is clockwise. Similarly, if the fixed beam is subjected to a concentrated load which is not at a midspan, so which is at a distance A from the support A and B from support B, the fixed end moments are PB squared A by L squared at left hand and PB A squared by L squared at the right hand. And for the UDL, the moment is WL squared by 12 at both ends, but it is anti-clockwise at the left, then clockwise at the right. Similarly, if you have a triangular load with maximum intensity at one of the support, so at that point the moment is fixed end moment is WL squared by 20. At the other end it is WL squared by 30. Similarly, you have a triangular load with the maximum intensity at middle of the span. The moment is 5 WL squared by 96. And this is we have already seen the moment due to settlement of support, that is 68 L by L square. And if the beam is subjected to a applied moment, then what is the fixed end moment? So whenever the beam is subjected to applied moment, the support moment also will be in the same direction. Suppose if there is a clockwise moment in the span, then the support moment also will be in the clockwise direction. And here I have given you the value of the fixed end moment, that is at the left support MB multiplied by 2A minus B divided by L square. At the right support MA by L square multiplied by 2B minus A. Now before going to solve this any problem, you should keep in mind there are some kind of sign conventions. See, in drawing the bending moment diagram, we have sagging moments are positive, hugging moment are negative. But in this case, we have to take the clockwise moments are positive and anti-clockwise moments are negative. So these are the moments, not the bending moments. These are the moments at the support. So bending moment, which is related to the flexure of the member. These are the joint moments. So we have to take clockwise moment as positive, anti-clockwise moment as negative. Similarly, clockwise rotations are positive, anti-clockwise rotations are